At Augsburg College, a Lutheran college in the heart of Minneapolis, the language of vocation, that learning is for the purpose of serving the world, is built into their culture and curriculum.
At Augsburg, when we talk to students about vocation, we always say the vocation question is never, what can I get out of it? The first question always is, what does my community need for me? It's not what can I get out of my community, but take a look around. Maybe your calling is actually being expressed out there in the needs of the community. So it's not about you, it's rather about the bigger picture and the larger, wider community around you.
For recent graduate Brian Kriohn, that focus on vocation served him well in his study of science and beyond.
Augsburg College does really stress an idea of having a vocation, and it's a topic that we cover a lot in our religion classes. And it was there that I first encountered the idea of not really settling for a career, but really finding where my passions were and how not just to serve myself in a career, but how to serve the community and serve the world. And that really was a driving force in how I moved forward after college.
As an undergraduate at Augsburg College, Brian was involved in a research project with chemistry professor Dr. Arlen Geiberg, looking into better ways to produce biodiesel fuel. What he discovered was a revolutionary new process that doesn't require using feedstocks and takes very little energy and space to operate.
Brian came to me and was interested in biodiesel.
And my advisor, Dr. Arlen Geiberg, he's a professor here at Augsburg for 40 years. So he's had a lot of students. And one of those students was Dr. Clayton McNeff, who did his PhD thesis on this compound called zirconia. And Dr. Geiberg and I, looking at the biodiesel literature, decided, well, maybe we could get some of this zirconia material for free from Dr. Clayton McNeff and try to use that in a new way to make biodiesel.
Clayton said, well, let's try this, and they did it out at Sartec, and it worked the first time.
Since then, it went from a small little lab scale reactor where I saw this clear liquid turn yellow to a pilot plant that could produce 70,000 gallons of biodiesel a year. And hopefully by the end of the summer, we will have a 3 million gallon a year biodiesel plant operational here in Minnesota.
This process is very earth-friendly, highly portable, and easily scalable, very different from conventional methods of producing biodiesel.
So to give you some idea of how the traditional process works, basically you take high-grade vegetable oil or animal fat, so very expensive feedstocks, and you put it in a vat and you add some caustic chemicals in there and stir it, and then it separates and you get biodiesel, soap, and this nasty waste products. And you have to do that in batch processes. But this new process is a continuous process. So you just have a tube that's filled with this catalyst, and you pump in not pure food grade vegetable oil, but any waste oil you can find. And as long as you can pump it through the reactor, it'll turn it into biodiesel in a matter of seconds versus 30 minutes to an hour with this big batch process.
One shortcoming is it takes about 4 or 5 gallons of water to make a gallon of biodiesel. Our process doesn't need any.
Another major benefit is the small size, because a 3 million gallon a year biodiesel plant only requires a reactor that's as tall as I am. So 6 feet tall, about a foot in diameter.
And we developed a laboratory version of a prototype for a reactor that'll fit on a pickup bed.
For Dr. Geiberg and Brian, the driving force for making this technology practical in the small scale was for use in developing countries.
As soon as this technology came along, the McNeffs at Sartec had the idea of scaling it down so that individual farmers could make their own fuel and be independent and, establish a fuel economy, a domestic fuel economy that benefits the farmers. It also benefits the consumers and benefits the environment because biodiesel emits 50% less emissions, harmful emissions, and if the vegetable oils come from a renewable source such as soybeans or algae or all sorts of other feedstocks, then you're not adding carbon to the atmosphere. So you're reducing your greenhouse emissions.
The idea to be able to produce a renewable fuel that doesn't compete with food and has the potential to meet not only our needs, but the world's needs.
This revolutionary new process has grabbed the attention of scientists and energy companies around the world as they anxiously await its release.
Well, as soon as this plant is operational, it is the first of its kind. This technology doesn't exist anywhere else in the world, and they already have people that are interested in purchasing this technology and putting it into practice.
Brian assumed that after graduation, he would do graduate studies in scientific research. But another opportunity came his way, and perhaps a new calling.
Recently, after college, I was awarded a Rhodes Scholarship, which is a scholarship to study at Oxford for 2 years. My degree will be a Master's in Science and Environmental Change and Management. And this is really exciting for me because the program looks at the intersection between academia, the technology, where does it come from, business, how do you sell the technology, how do you implement it, and government, what policies can you enact that will encourage business to make good choices and implement this new technology. So I'm really excited to learn about that. So again, I think it's the idea of following a vocation, where does life take you, and pursuing what you're really interested in.